So we're going to do 2 problems in class, kind of like we did yesterday, and then I'm going to give you some time in class to work on them. But I want to show you a couple of examples with quadratic formula. All right, so here we go. This was our method that we used yesterday. We said we determined like how many possible zeros to synthetic division, and then either factor or use the quadratic formula, that's what we're going to do today. We'll rewrite that out if you didn't write down yesterday. But let's take a look at this first one here. Putting all the stuff we've learned really from this chapter into one problem. All right, so let's start by writing out the total number of zeros, which is going to be 3, obviously. And next, positive real. So how many positive reals have we got? 0. Yeah, none, because there's no sign changes. No positive real numbers. All right, for negative real, we're going to want to replace all the x's with negative x. If you can do these in your head, that's okay. Just make sure you're careful when you plug that in. I'm going to write it out. But remember, if it's odd, then it will be negative. So this is odd, it's third power, so it'll be negative 3x cubed. And even, we'll make it positive. Odd there, minus 4x plus 1. So how many negative reals? Yeah, 3 or 1, right? We got 1, 2, 3 sign changes. So 3 or 1. And imaginaries, right, either 0 or 2, because if we have 0 and 3, that would be all 3 of them, so that means we'd have no imaginaries. If we had 0 and 1, that would only be 1 of them, and we need 2 more, so that's why we get 0 and 2. All right, now let's see our possibilities. The list is pretty short on this of possible ones. So we want to do our P, which is the factors of 1, which is 1. Q is the factors of 3, which are only 1 and 3. So then our list is pretty short. We're just going to do 1 over 1 and 1 over 3, or plus or minus. Plus or minus 1, plus or minus 1. All right. So what do you guys want to do to start? Which one should we try? Try 1? Okay. So with this one, rather than write out the 1, I want to just show you a couple things that might save you some time. One thing would be, you can envision just kind of plug it in your head up here. Notice how all of these are positives. If you plug in 1, it'll be like 3 plus 4 plus 4 plus 1. Think you'll get 0? No, because you're adding a bunch of positive numbers, right? How could you get 0 to add those positives? That's not going to work. And also, another thing I want to draw your attention to, what was this? No positive real numbers, right? So we actually don't even want to try a positive number because we know that's not going to be one of the answers. I'll save some time. So let's try, we could try -1, might be the next best choice, right? We don't have to go into the fraction. So let's try that. That might work. You can maybe do that in your head, but if not, let's go ahead and do it here. Let's do synthetic division, -1. So we get 3, 4, 4, 1. And let's go ahead and do that. 3, -3, 3. And unfortunately, it doesn't look like that's going to work out. We did not get 0. We only got one other option then, right? -1/3. Because it's not going to be a positive 1/3. So let's try -1/3. got our same numbers up here, 3, 4, 4, 1. I know fractions can be a little intimidating, but generally they work out to be pretty nice numbers. So we drop down our 3. What's 3 times negative a third? Yeah, negative 1. So it ends up, all of them are pretty good numbers. 4 plus negative 1 is 3. So then what's 3 times negative a third? Let's have that out, right? Negative 1 again. Add them up, we get 3 again. Just 3 times negative a third. It's still negative 1, hasn't changed yet. So it is 0. That's good. So negative a third is a 0. Now let's write out our equation. We got this one here. Is this going to be x minus 1/3 or x plus 1/3? It's actually going to become plus. The reason I ask for that is like, think about when we have like 2 here, and then it becomes x minus 2, right? This one is always going to be the opposite because it's like x minus negative a third. So it actually is x plus 1/3. So think about when you solve it, when you set this equal to 0 and solve it, it becomes negative a third. So we want to write it as x plus 1/3. And then here we've got 3x squared plus 3x plus 3. All right. So that one's looks like a challenge factor. Now there is one thing we can do to make this look a little bit easier. If you look at this, what could you do to this? Yeah, notice how they all have a 3 in them. So you can actually pull the 3 out. It's called like factoring out the greatest common factor. Like, can you shut that door for me too? While you're up there. So we're going to pull the 3 out. I'm actually going to write it in front. Plus 1/3. And then this just becomes x squared plus x plus 1. So I just pulled the 3 out and just wrote it. Okay, so that at least makes it look a little bit easier. Now let's see if we can factor this. X squared plus x plus 1. So when you're factoring, you need to think about multiplies to give you 1 and adds to give you 1. Anybody think of when multiplies to give you 1 and adds to give you 1? It's not possible. Because the only factors of 1 are 1 and 1, right? If you add 1 and 1 and get 1, and get 2, if you subtract them, then you get 0. So this is not factorable. Which means this is going to be our final factored form, but we haven't found the zeros yet. This is going to be our factored form. But we haven't found the zeros. We still need to find the zeros. So we can't just quit there. So if we can't factor something, then we have to bust out the quadratic formula. So, all right. So yesterday I told you what it was. I'll rewrite it out. This is good practice too, like if you have to take an ACT or something like that. Negative b plus or minus square root of b squared minus square c all over 2a. Someone in the second period said they actually had never used the quadratic formula before. If you haven't, it's okay, I'll give you a little explanation how to use it. So the A's, B's, and C's come from, this is our equation here, I'll flip it up and stuff up here. So the A is whatever number's in front of here. So A is just going to be 1 in this case, because there's an invisible 1 there. B is whatever number's in front of the second term, it's also just a 1. And then C is whatever the constant is, and it's also just a 1. So in this case, it's kind of the easy case, they're all 1. That's where they come from. So then you would take the A, the B, and the C, and you plug them into here. So let's see what happens. Negative 1, because it's negative B, plus or minus, square root of 1 squared minus 4 times 1 times 1. all over 2 times 1. So we just plug in our A's, B's, and C's. And then we just try to simplify this as the best we can. So we get negative 1 plus or minus the square root. This is 1, right? So 1 squared is 1 minus 4. So 1 minus 4 is 2. Now, up to this point, we haven't had any imaginary answers. This is actually an imaginary number because we have a negative inside of the square root. So we're just going to write it this way. Negative 1 plus or minus the square root of 3i. I stands for imaginary. And we're just going to leave it like this. There's not really any simplifying you can do. And this is 2 answers because we got the plus and we got the minus. So this is actually 2 of our solutions. It's the 2 imaginary solutions here, which was a possibility. And then we had the 1 negative real. That was the negative 1/3. So those are 3 solutions. So everything's the same up until this point. Just isn't factorable. And the 2 problems I'm going to give you to work on your own are going to be the same. They're not going to be factorable, so then you have to plug them. We'll do one more together here. Let's try out this one. So total number of zeros, again, is 3. How many positive real? Now we got 1, 2, 3 side changes. Yeah. So it's 3 or 1. Which means how many negative reals? Yeah, there's none. Negative reals is none. I can tell you that without actually doing it because these 2 can never add to give you more than the total. You're going to have a possibility of having more positive and negative reals more than the total amount. So if this is 3, this has to be 0. Right? You can still do it if you wanted to. And recognize that this would become negative x cubed. This would be negative x squared. This would be minus 28x, and minus 16. And they'd all be negative, so there'd be a 0 sign changes. All right, and then so imaginaries. If we had 3 and 0, then it'd be 0, right? If we had 1 and 0, then it'd be 2. So 0 or 2. All right, let's list our possibilities here. Our p is 16. What are the factors of 16? 1, 2, 4, 8, 16. Very good. 1 and 16, 2 and 8, and 4 and 4. And the q is 1. So that's going to make it a little bit easier. And it's just going to be all of these 1 over 1, 2 over 1, 4 over 1. So it's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Now we know there's no real negatives, so we can throw out actually all the negatives. We know it's got to be a positive number. Now we just got to figure out what the positive number is. Where do you guys want to start?
2.
Start with 2? Okay, we can try that. do the math here. 1, 2, 8, 12. Unfortunately, you do not get a 0. What do I try next? 4? Okay, try 4. 4, 6, negative 4, 6, and 0. Yeah. Very good. That works. So we got our 1. That's all we need for now. So we got x minus 4. And then our equation is just 1x squared, just x squared, minus 6x plus 4. You guys think we can factor that one? Probably not, since I'm going to give it to you, right? But let's think about y. So your factors of 4 could be 1 and 4. Could you combine 1 and 4 to get 6? No, you get 5 or 3, right? Or 2 and 2. You combine 2 and 2 to get 6. Not happening. So they're not factorable again. There's nothing you can pull out of here. There's no common factor. So we'll just go straight from here to the quadratic formula. So this would be our factor form. Right. So that's our factor form. Don't factor it anymore. But let's go ahead and try to find our solutions. And the A, the B, and the C. So A is 1. It is helpful, I think, to write those out. A is going to be 1. B is negative 6. And C is 4. Plugging those in. The B is a negative B, and this is already negative. So it's going to be like negative 6, which is just positive 6. Also minus the square root of negative 6 squared minus 4 times 1 and 4. All over 2 times 1. So I want to try to simplify that as much as we can. We'll get 6 plus or minus square root of 36, because negative square root is positive. 36 minus 16. 36 minus 16 would be what? So x equals 6 plus or minus the square root of 20 over 2. Doesn't look pretty, I know. If you leave your answer like this, I'm okay with that. If you want to leave it like this, well, I'll show you how to simplify a little bit more. So that's the fine answer. If you went ahead and made it decimals, that would be fine as well. But you can actually simplify this. If you don't know how to simplify radicals, though, you wouldn't be able to do it. But what we would try to do is simplify the square root of 20, and this would become plus or minus the square root of 20 has a perfect square in it, it's 4. So look at it as like 4 times 5. And then the square root of 4 is 2. So it becomes 6 plus or minus 2 radical 5 over 2. And then you can actually do one more thing. This is divisible by 2, and that is as well. This will become 3 plus or minus the square root of 5. So that would actually be what like your book would say, and then maybe 3 plus or minus radical 5. It's the same answer as this, it's just that's the simple thing. You can try it, yeah. If you've ever done it before, yeah. So that'd be the simplified version. If you also did decimals, that's fine as well. But we actually, these would all be positive. These are both positive. Because the square root of 5 would be like 2.1 or 2.2. So 3 plus 2.2 or whatever would be 5 point something. 3 minus it would be a decimal, would be a positive. So there's actually 3 positive reals. This is the only one that's a rational number, 4. Those are irrational. Those are 3 solutions. So I'm going to give you quite a bit of time to work on these in class. You have 20 minutes, so I want you to practice so you can ask questions if you need to. If you want to like even move and work with someone on, you can. But I've got 2 problems for you to do, very similar to this. And one of them is actually on the next page. I couldn't find one that I really wanted on the first page, so I changed it to one on the next page. The directions are going to be slightly different, but I just want you to do number 77 like we've been doing.